Now we can make glass with a 3D printer. A group of German researchers have developed a new method for making glass with 3D printing technology. The 3D printed glass is made from a mixture of glass nanoparticles and a photocurable liquid, which acts as a binding agent. Through a method known as stereolithography, the mixture is shaped and hardened after exposure to UV light. Any remaining liquid is burnt away by high heat, which further fuses the glass nanoparticles together. Researchers say the 3D printed glass can be used for anything from building skyscraper facades to camera lenses for smartphones. Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews. Keep watching for the latest developments in 3D printing technology. 3D printed organ on a chip could end animal testing. Harvard scientists have developed a 3D printed heart on a computer chip, which can be used to study heart conditions without testing medical treatments on animals. The heart on a chip is composed of a small piece of flexible polymer that contains living human heart cells which can mimic the physiological response of a human heart. The chip also contains integrated sensors. The sensors collect data on the beating of the heart on a chip, which can be used to study how the tissue responds to drugs or toxins. Other organs, including bones, lungs, the liver, and gut, can also be made into organs on a chip. Backers of the technology say it is a more accurate alternative to testing drugs on animals, and hope it can decrease the number of animals used for testing.
MIT researchers create 3D printed robot skin. These robot cubes are wearing MIT's latest creation. Researchers at MIT have developed 3D printed skin for robots. The skin protects robots and helps make their movements more precise. The skin is made of a programmable viscoelastic material. Unlike purely elastic substances, a viscoelastic substance has an elastic component and a viscous component. Viscoelastics are able to dissipate or dampen energy where elastics cannot. Through 3D printing, the skin's elasticity can be manipulated by altering the amount of liquid material inside. A solid, a liquid, and a flexible rubber-like material called Tango Black Plus were used in the printing process during testing. When tested on bouncing robots, the creations with more liquid concentrated skin bounced higher and landed with more precision. The work was supported by a grant from the National Science Foundation. Amsterdam to get the world's first 3D printed pedestrian bridge. A Dutch startup company has announced plans to draw a steel structure over water in Amsterdam. Dutch company MX3D plans to print a bridge across an Amsterdam canal, with the project set to begin in September. The computer program plots designs while robotic arms heat metal to 1,500 degrees Celsius, around 2,700 degrees Fahrenheit, to weld structures drop by drop. This technique removes the need for scaffolding and people, as the robotic arms are supported by the very structure they are printing. This essentially means robotic arms will walk across the canal as a bridge is being created. According to the company, this technique could become standard on future construction projects, especially on high-rise structures that are more dangerous for human builders.
Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews.
A technology that can produce lithium-ion microbatteries with 3D printers has been developed by Harvard scientist Jennifer Lewis. To make the ink, nanoparticles of lithium titanium oxide are added to a vial of deionized water and ethylene glycol. Ceramic balls are used as agitators to break down the particles. The mixture is spun for 24 hours. The balls and larger particles are removed with filters in a centrifuge. The resulting ink is placed in a syringe and inserted into a high-pressure dispenser on a 3D printer. The ink is solid when unperturbed, but flows under high pressure. The ink is printed on a glass substrate with a gold current collector, where it solidifies to create the battery's anode and cathode. A tiny container filled with an electrolyte solution encloses the electrodes to complete the battery. The printed battery is about 1 millimeter square. The batteries could be used in miniaturized medical implants, compact electronics, and tiny robots. The technology is still at an early stage, but the ability to print batteries and other electronics could make it possible to manufacture new kinds of small devices.